Okay, this is what we have understood. Just by doing the specification properly, we have gained a lot. What will happen if we do system GMM? System GMM means in this I will remove and I will estimate when I am doing this, then again NL1 which was lying earlier within the interval, now it is going to 1.06. So, probably I will, what I have to do is, when I am doing this system GMM, then I need to estimate, instead of here what I am doing one step system GMM. So, one step system GMM, it has a problem. What is the problem? I will discuss that later. So, for the timing, I will estimate a two step system GMM model. So, here I will simply put two step, then I do not require this. So, two step system GMM, and since this is a system GMM that we are estimating, we need to put that no cons command also, because no cons will remove the constant from the x and z, and then if we do so, so it is just lying 1.08, it is still outside the bound. So, that means basically what I am saying, this is the, with this example what we are trying to see is that the specification actually matters a lot. Okay, specification matters a lot. So, here I am saying I am getting 1.08 again, which is lying outside the interval, but when we have estimated a difference GMM, right, one step difference GMM, within that specification it is lying within the interval. So, basically what I am trying to convey here is, whatever model we estimate, whether we estimate a difference GMM, whether we estimate a system GMM, whether we specify what variable we specify as endogenous, what variable we specify as exogenous, those things actually matters a lot. So, one thing what we have to do is, the moment we get a model, we first get its OLS estimation, then we will get its fixed effect estimation to get the limit, upper limit and lower limit. Once we get the limit, then we will estimate the model, either system or difference, either one step or two step. After that, we will see whether the estimates are lying within the interval or not. Until and unless our estimates are lying within the interval, we need to keep on changing our model specification. Here we have changed two variables, they are used as earlier they are used as exogenous, now they are endogenous. Now, how do you know whether those variables should be exogenous or endogenous? Probably the technique what we have learned earlier, we have to run a simple panel data model, fixed effect panel data model, and then some test of endogeneity like Wu-Hofmann test or Hofmann test of endogeneity. We should run some kind of endogeneity test to check whether those variables are actually endogenous or not. Depending on those results, we will put our final specification in the context of this dynamic panel, and then until and unless our estimates are lying within the interval, we need to play around with our specification. Here we have played only with changing exogenous and endogenous variables. Probably it also depends on how many lags you are using as your instruments. Look at here. Here the number of instruments are 90. So, when we are using this model, number of instruments in system GMM is 112. So, it is very, very difficult to ensure over identifying restrictions for all these 112 instruments, right. So, we will learn how to restrict the number of instrument as well later on. For the time being, what I should also convey to you, so far we are always talking about over identifying restrictions, whether they are all the instruments are satisfying over identifying restrictions or not. Before we talk about those, that means the second post estimation checkup, even though they are satisfied here, look at here, over identifying restriction, Hausmann test of over identifying restriction is 0.637. So, that means what is the null hypothesis? Null hypothesis is that over identifying restrictions are valid. So, we are unable to reject the null, but Sargent rejects the null hypothesis. Before we go, we talk about this, let us now take little bit of theoretical concept which will help you to understand what exactly is the over identification we are talking about in the context of a GMM estimation. So, here let us talk about now testing for over identifying restrictions, that we are saying testing for over identifying restrictions. Right. So, this is our model, YIT equals to rho YI t minus 1 plus beta XIT plus AI plus VIT. This is our model, and let us assume that there are only 4 periods. That means T equals to 4 in this panel. Okay, T equals to 4. So, Arellano and Bond 1991 gave us the 3 moment conditions to estimate the model. As you know that this entire technology, entire methodology depends on method of moments. So, if we assume T equals to 4, in this particular example, Arellano and Bond, they gave us 3 moment condition. What are those? Expectation yi1, then you have vi3 minus vi2 equals to 0, right. So, when you have T equals to 4, that means for third period you will have only yi3 second lag. When you go to fourth period, then you will have both yi2 as well as yi1. Okay. yi2 will be following that Arellano-Bond's logic, yit minus 2 means 4 minus 2 is 2, yi2, yi1 is also available because third order lag is also available in the fourth period. That is why we will get moment condition with respect to yi1 and yi2. yi1 for both third and fourth period, and yi2 is only for the fourth period. So, accordingly 3 moment condition, and then second moment condition would be again yi1 and then vi4 minus vi3, that is also equals to 0, and then third moment condition is yi2 vi4 minus vi2, that is also 0. So, these are the 3 moment conditions that we got from Arellano bonds, and any of these 3 moments, any of these 3 moments, any of these 3 moment conditions can be used to estimate rho. Okay, to estimate rho, that means this. So, rho means this. Okay. As you know, what is GMM basically? GMM is taking this population moment condition and converting into a corresponding sample moment condition, and when you have more than one moment condition like the way what we are getting here. So, the remaining moment conditions, the remaining moment conditions the remaining two moment conditions are actually basically over identifying restrictions. Okay, we need only one moment conditions, but we have 3. So, the remaining 2 are actually the over identifying restrictions that we are putting in the model. So, using Monte Carlo simulations, okay, Monte Carlo experiments. So, now since you have 2 moment conditions, we need to construct a test for over identification, and the first test is Sargent's test. Okay, Sargent's test constructed within this particular context. Now, Sargent test, what happens using the Monte Carlo experiments. So, how do you check this? Either by Sargent or by Hansen. Sometimes this is known as J statistic. You have 2 tests when you have this type of over identifying restriction, 2 tests. Now, using Monte Carlo experiments, what the Bowser Bowser 2002, they found that the use of too many instruments, too many moment conditions too many moment conditions cause Sargent test to be undersized, test statistic which follows a chi-square distribution actually. The Sargent test statistic to be undersized and have extremely low power. Extremely low power. So, what is the solution then? The solution is the so what is the problem? So, in Sargent test what happens here? When it becomes undersized and having extremely low power, then Sargent test what it does? Sargent test basically does two things: rejects the null, almost all the times when t is small, and secondly never reject the null when t is large. That is the problem. Okay, this is the problem of Sargent's test. And then when we go for Hansen test of over identifying restriction, Hansen test of over identification so it basically depends on again a function which we have discussed earlier. Recall that the GMM the GMM criterion function or quadratic loss function that we have used earlier, Q equals to 1 by n summation Z I and then U I beta transpose W the weight matrix into 1 by n summation Z I ui beta. So, this is the quadratic loss function. Okay. So, it all depends on this Hansen, basically Hansen test depends on this quadratic loss function. How? This is the quadratic loss function. If you go back, you can see this quadratic loss function. Instead of ui, what we have defined earlier, yi minus xib. Here also yi minus xib, that transpose, and w is basically that L by L weight matrix. Okay. Then the test of over identification is very simple. And how do you do this? So, basically if w is an optimal weight matrix under the null hypothesis, which is H naught. What is the null hypothesis? H naught, expectation of zi ui beta the test statistic which is J in the context of Hansen is basically N cross Q, which follows a chi-square distribution of L minus K. Okay. Right. So, I am multiplying total number of observations with this Q. Q is basically a quadratic loss function, right. So, for the test to be valid, W must be optimal. That means that W must be the inverse of the covariance matrix of the moment condition. Okay. So, that means basically what I am saying, this implies W inverse equals to expectation z I ui b ui beta Zi prime. This should be my Wi, W inverse, right. So, this is how the Hansen test of over identification is defined, and then if you see in this way, the way this Hansen test is defined, it actually depends on it depends on the calculation of the test statistic in Hansen test of over identification is basically depends on the quadratic loss function. Okay, quadratic loss function. And what is the quadratic loss function? This is my quadratic loss function. And then if you see the advantage of this Hansen test, in almost all the cases, Hansen test is saying that over identifying restrictions are basically valid. So, what we have learned today then? We have learned today how to use that xt_2 command to estimate a system GMM model, and then we have also learned how the quality of the estimate changes drastically if we change the model specification. That means, the difference GMM which was not ensuring the estimates to lie within the interval of FE and OLS estimates, upper and lower bound, the moment we changed wage and capital also to be endogenous, it changed drastically and pushed the estimate to lie within the interval. And then we learned about system GMM, and we have also talked about the second post estimation checkup, which is given after this xt_2 command, which is by Sargent and Hansen test. And then we showed that Sargent test, it has some problem in a sense. In many cases, Sargent test actually, what we have written here, look at here, what we said, that there are two tests to test for whether identifying restrictions are valid or not. One is Sargent, second one is Hansen, and then this use of too many moment conditions. That means, when you have a relatively larger time periods, that means if you have too many instruments when you are using, then the Sargent test is undersized and the power of the test also becomes extremely low. Okay? And that is why what it does, it rejects the null almost all the times when the t is small, and almost never reject the null when t is large. That is the problem of Sargent test. And then we go for Hansen test of over identification, which is basically depending on the quadratic loss function. So, this is the second post estimation checkup. But one thing, then the most important thing what we have to keep in mind, that whatever model we estimate, either system or difference GMM, the specification of the model should be correct in terms of what is exogenous, what is endogenous variable, right. So, now there must be a test actually in Stata. What we are doing here, if you look at the command, if you look at the command how we are writing, we are specifying the model first and then we are specifying which is endogenous, which is exogenous by this GMM style and IV style, right. So, there must be a test whether this specification is correct or not, and that is also given in Stata. If you look at after Sargent and Hansen test, they are also telling you the difference in Hansen test of exogeneity. Okay. So, we will talk about this thing later, right. So, with this we are closing our discussion today, and in our next class we will be all discussing some of these post estimation checkups, and also we will learn how to control the number of lags, because when too many instruments are using, too many moment conditions are using, we are using too many moment conditions, because here we have no control. We have not specified on the number of controls. So, look at here, we are using how many controls from first period to 8th period of N, W and K, and that is why number of instruments becoming exponential, and the number of instruments used can also determine the quality of the estimates, right. So, how to control for the number of lags, that we will learn later on. So, with this we are closing our discussion today. Thank you.